And then we solve few problems on parallel and transverse fillet welds. Then we will move on to the eccentrically loaded welded joints, okay, wherein the load is applied in transverse direction, okay. And then we learned about the design procedure wherein, so first step is to find out total length of the weld, L, then direct load per unit length, then locate center of gravity, use table 6.7 of your data handbook. Then find eccentricity. Eccentricity is the distance between center of gravity to the point of application of load. Okay, that is eccentricity. Be careful while extracting this data from the given problem. Okay, and then find out cos theta, and then find out the radius of the weld, radius to the weld. Then find out polar moment of inertia. An important thing is from the handbook, you have to ignore HT value in the beginning because that's what we find at the end, right? So then find out twisting moment per unit length given by PER by JW, then resultant load and shear stress. All right. So which one had we taken this problem? Had we started with this problem, or we have just taken the procedure? What did we do in the last class?
We didn't do the problems.
We didn't do the problem, but the procedure we have taken, is it?
Yes, sir.
Okay. So let's take up a problem. This was asked for 10 marks. Please note down. Determine the size of the weld required. Determine the size of the weld required Please note down the problem. Please note down the problem. I hope it is visible for you all. All right. So determine the size of the weld required for a flat plate welded to a steel column and loaded as shown in figure. The permissible shear stress for the weld material is 70 megapascal. Just note on this problem. Note on this problem. Determine the size of the weld required for a flat plate welded to a steel column. This is the flat plate welded to a steel column and loaded as shown in figure. The permissible shear stress for the weld material is 70 megapascal. All right. Noted. Please note this sketch also. Please note whatever the blue line that is shown here represents weld. Okay, that is been. So normally in question papers they may indicate it with lines also or grid-like thing, something like that they will show. So here I have shown it by blue lines over here. Okay, this represents weld. Note down this sketch clearly. It's very easy. Okay, normally you will have a problem based on this for 10 marks. So it's very easy. Just follow the procedure, substitute the values and get the required parameters. Yeah, taken. Did you note down the sketch here?
Yes, sir.
Finished, yeah? Okay. Don't do anything. Just hold on for a while. All right. So this is the sketch that we have taken for the welded joint. So this is the value of N. This is the value of M. Again, this is the value of N. Right. So comparing that over here, right, the same figure I have given here also. The value of N is going to be equal to 200 mm. Value of M is 300. Okay, value of M is 300 out there, and then again, so this is M, this is N. This distance is 500, but that is not eccentricity, and the load that is acting is 60 kilonewton, that is 60,000 Newton, and the permissible shear stress for the weld material is 70 megapascal. Because of this transverse load, there is going to be rotation about the center of gravity. So therefore, the stress induced is the shear stress 70 megapascal. Okay. So now, what is the first step that we need to take? The first step is to find total length of the weld. That is N plus M plus N. That is 200. Total length of the weld is 200 plus 300 plus 200. That is 200. That is here 200, 300, and plus again 200. Put together will give you total length of the weld is equal to 700 millimeter. Okay. Next step is to find direct load per unit length, that is given by load by total length of the weld L. So P given in the problem is 60 kilonewton. So 60,000 divided by 700 is the total length of the weld. Divide P by L, you will get load per unit length. So for every millimeter, what is the load that is carried is what we get in direct load per unit length. Then locate CG of the welded joint. So go to table 6.7 in page number 96 of your data handbook. Ny is given by n square by 2n plus m, but in data handbook he has given it as 2 of n plus m, but change it to 2n plus m for such type of welded joints. Okay, so n is 200, 2n, 2 into 200 plus m is 300. Substitute, you will get the value of center of gravity. That is, you will get the value of ny. This is ny, correct? This distance is ny. Am I correct? Yeah? Am I correct? Anybody? Are you there?
Yes, sir. Yes.
Suddenly I get confused. I say if nobody is answering. Huh? Okay. So what is this value in that case? What is this value that we have taken in the sketch previously? Or you observe here also? Yeah? What is this distance? From CG, N1, okay? N1. Okay, so find out N1, which is nothing but N minus Ny will give you the value of N1. Okay, so then find out radius of the weld, that is from here, this is radius. So you have adjacent side, you have opposite side with respect to theta over here. Okay, so it's by using Pythagoras theorem, r is equal to root of m square, that is m by 2. This distance is m by 2, correct? So this also we have learnt in the previous session. So this is m by 2 and this distance is n1. Okay, so therefore n1 square plus m by 2 square under square root will give you the value of radius. And then find out eccentricity. Once you know the value of n1 here, 500 plus n1 will give you eccentricity. Are you there? So this is eccentricity, correct? That is from center of distance between center of gravity of the weld to the point of application of load is the eccentricity E. So therefore in this case it's going to be 500 plus n1 will give you the eccentricity. Then find out cos theta, which is adjacent by hypotenuse, that is n1 for this triangle. It is n1, this distance is n1 by r will give you cos theta. Then find out polar moment of inertia using the equation from table 6.7 for that type of weld, and then follow the steps and get the value. Is it okay? Are you there?
Yes, sir.
Yeah. Please note down, solve and check if there is any variation or deviation from from the values that you have calculated. From the values that I have calculated. Is that okay? Just follow those steps. You will get the answer, right? So please do, and let me know once you complete this page. Okay. Meantime, answer your roll call. Yeah, size 1,
Answer.
2, 3, 4, 5,
Yes, sir.
6, Akram Anwar, 7, 8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Yes, sir.
12,
Present, sir.
13, 14,
Present, sir.
15,
Present, sir.
17,
Present, sir.
18, 19, 20, 21, 22,
Present, sir.
23,
Yes, sir.
24, 25, 26,
Present, sir.
27, 28, 30, 31, 32, 33, 34,
Yes, sir.
35, 36, 37, 38, 39, 40,
Yes, sir.
41, 42,
Yes, sir.
43, 44,
Present, sir.
45, 46, 47,
Yes, sir.
48,
Yes, sir.
49,
Yes, sir.
50,
Yes, sir.
52, 53, Chandriyal, 54,
Yes, sir. Present.
55, 56, 57, 59, 58, 59, 60,
Yes, sir.
61,
Yes, sir.
62,
Yes, sir.
63,
Yes, sir.
65, 66,
Present, sir.
67,
So can you change the
Chaitanya,
slide?
Chaitanya, Mahesh Madiwal, Nishant, Ramesh, Shashank, Akshat,
Present, sir.
Sautri Krai,
Present, sir.
Mahima Raj,
Present, sir.
Srivatsan,
Present, sir.
Suman Xavier, Madan Kumar, Manu, Shada, Ganesh,
Present, sir.
Vijay Kumar, Rishi, Zair Hussain. Yeah, are you getting these values? Any variation? Mule Patti, any variation?
No, sir.
Okay, shall we go to the next page? Yeah. So next is to find out polar moment of inertia in torsion JW. Use appropriate equation from table 6.7 in page number 96 of your data handbook. Substitute properly and get the value of JW. If there's any variation, please let me know. And after that, find out twisting moment per unit length. Pn is equal to Per by Jw. E stands for eccentricity. P is the total load. R is the radius of the weld. Jw is the polar moment of inertia in torsion. Okay. Get the value of twisting moment per unit length. Actually, it is not per unit length. Anyway, let's then find out resultant load PR. This is going to be PR. Then find the size of the weld. Complete this. Once you say yes, we will go to the next problem.
So the formula shows HT before the whole formula of polar moment of inertia.
That is
What is that?
what I had given you here as note. Ignore HT value while calculating
Okay, sir.
JW. Right? Yeah.
Done, sir.
Done, na? Okay. Anybody else needing more time?
No, sir.
Yeah. We'll go to the next problem now. Right. So take down this problem. Again, this was asked for 10 marks. Okay. A 16 mm thick plate is welded to a vertical support by two fillet welds as shown in figure. Determine the size of the weld if the permissible shear stress for the weld material is 75 megapascal. Note down the values of N and M over here. This is 250. Load is 20 kilonewton. So choose appropriate equations and be careful. So page number table 6.7 in page number 96. Location of CG. So you have to find out MX. Okay. And then you have to find out NY both. Why you need MX is because in the previous case it was very clear M by 2. But here it's not going to be M by 2. For calculation of radius, it's going to be MX square, right? So therefore you have to find out MX and NY both. So take this problem, calculate, and if you have any doubt, just follow the procedure. I told you what is the difference between the previous problem. So here it is MX is what we need to find out. Okay. That value is what we are going to take while calculating the radius of the weld, or here the value of R. But whereas in the previous case, it was M by 2, but in this case, it's not going to be M by 2 because it's not a symmetrical weld. Okay? Got it? So please solve the problem. Calculate and let me know what is the size of the weld. Total length of the weld is going to be 100 plus 50 because there's no Look at the sketch in table 6.7 for L type of welded joint. You have MX and NY, right? That is, you have CG somewhere here. So your radius is out there. This is going to be value of N, and this is MX. And this is N1. Okay? That's why we need to find the value of MX. It is not straight away M by 2. Anybody, any doubt in this? Just look at the sketch in the data handbook. You will get MX is equal to M square by 2 of N plus M. And NY is N square by 2 of N plus M again. Okay. So once you know the value of NY, we can find the value of N1, right? So once we know the value of NY, we can find N1, and MX anyway we can calculate from the given equation. So therefore you have R is this is R, okay? R is equal to root of N1 square plus m square. Okay. Here it is n1 square plus m square x. Okay. There's no bracket over here. Give me the value of JW once you calculate, okay? Any variation in the values? Any variation?
No, sir.
Fine. Calculate JW and weld size.
So GW I got 852083.3.
852083. Okay, 852.08 into 1000. Correct? Huh?
Yes, sir.
Either way, you can use as it is, or can use this way, right? Others, please check whether your answers are whether your answer is correct. Look for JW. It is 852 into 1000. In such case, Pn you are going to get is 710.9 Newton. Then find out resultant load. Okay, and then you will get the weld size. Check whether you are getting
Show the
this.
previous page once.
Pardon me?
And show the previous page.
Yeah. This is theta. So cos theta is adjacent by hypotenuse. Therefore, it's N1 by R. This was asked for 10 marks. So always remember eccentricity is with reference to CG, okay? And to the point of application of load. This is eccentricity. Don't make mistake in taking eccentricity. This is eccentricity, okay? The moment you take 250 as eccentricity, you are off, okay? You will be left with only 3 marks out of 10 marks. So please remember that, okay? So be careful while choosing the data from the given problem. Finished?
1 minute, sir.
Yeah.
Yes, sir.
Do it, learn it, do it, learn it. Every topic is important because when you go for higher, placements and all, okay. So they may ask in one particular field. So we don't know which that field will be, unless otherwise we do thoroughly we check what that company is needing, right? So they may ask you about welded joints and fixtures for welded joints and so on. So we cannot neglect anything. So try to learn and remember as much as possible. So what that you have studied. Okay.
So how did we get theta value?
Cos theta. What is theta? So once again. Okay. Have you taken the sketch over there?
Yes, sir.
I think you have forgotten probably. Okay. What is theta here? This is theta, correct?
Yes, sir.
Okay. This is N1. Okay. Correct? This is
Yes.
radius. So cos theta is adjacent by hypotenuse. That's what I've been telling. Right?
Okay, sir. Okay, sir. Got it.
Correct? Huh?
Yes, sir.
Okay. Sin theta is what, Chinmay?
Opposite by hypotenuse.
Opposite by hypotenuse. Okay. Tan theta?
Opposite by adjacent.
Excellent. That is sin theta by cos theta. Okay.
Cos theta.
Yeah. Fine. Simply I asked. Okay.
Yes,
Not
sir.
that you will not be knowing. Simply to refresh. Huh?
Yes, sir.
Okay. Finished. Shall we go to the next problem?
Done, sir.
Yeah. Anybody else needing time? Anybody needing more time to note it down? Okay, then we'll go to the next problem. Take this problem. Again, this was asked for 10 marks. A bucket carrying a load of 15 kilonewton is to be welded as shown in figure. Find the size of the weld required if the allowable shear stress is not to exceed 80 megapascal. All right. So here he has given you the value of eccentricity straight away. Okay. Please note down the sketch, note down the problem, and solve the problem. Note down the sketch. Yeah. Note down the problem and the sketch and solve the problem and let me know the answer. Please solve. Load is 15 kilonewton. Akshat BS, are you working?
Yes, sir.
Yeah. Ankit Gangadharan Nambiar, are you there?
Yes, sir.
Where were you for so long?
So I had to go to Kerala because my grandmom was sick.
For what?
No, so my grandmom was sick, so I had to go stay with her for a few weeks.
Yeah, there's no internet there in Kerala.
No, so I tried with mobile data, but it wasn't good at all. Sir.
Hey, what you are talking, I say? Eh? Every village has got connectivity, and you are telling.
No, so I hardly got like 3G there, sir.
What is this? These things won't help you, man. I'm telling you. Okay. You have to learn. Okay. Why? Why you have to go to your grandmother's place?
No, sir, she was sick, so.
Okay. For 2 weeks, what you are doing? Your father will take care of her mother, his mother. No. What you are doing?
My mom and I had to go, sir.
What, man? Will she allow you to lose classes like this for 3 weeks? I don't think so. You people are not so intensely connected to the course. That is a problem, I think. Yeah. You have to connect yourself intensely, I say. Otherwise, competition is too hard. If you are so cool and calm, you should not join technical courses. You should go to some BA, journalism, mass communication, all these things, no? Where you have to go around and travel, blogging, travel blogs, all those things you can do. Finally, if everything you get tired, then other things. Okay, Mr. Gangadhar Nambiar, are you getting what I'm telling?
Yes, sir.
Once you are into technical course, you have to be intensely involved. Otherwise, there's no point. Vinay J, are you there? Vinay.
Yes, sir.
Yeshwantpur, Yeshwantpur or you are only, no? Yeshwantpur.
Yes, sir.
Okay. So learn. Otherwise, you can't do anything. I'll tell you. After BE, if you cannot tell the definition of welding, nobody will take you. If you don't answer what is stress strain diagram, nobody will take you. If you say, I don't know what is the difference between first angle and third angle projection, nobody will take you. Okay? So these are the things you have to keep in mind. Yeah, what is the answer now? I want the answer for weld size. Got to be faster. What is total length of the weld now?
100 mm.
Yeah, 100 mm is the total length. 50 plus 50, 100 mm. Next, direct load per unit length is 15,000 divided by 100. That will give you 150 Newton per millimeter. Radius is n by 2 square plus m by 2 square, okay? And your CG is going to be at the center, correct? You look at the data handbook over there, okay? For this type of weld, CG is directly available, right? So first four, getting CG is simple. Last two types of weld, that is L joint and C joint, okay? So you need to find out NY. Otherwise, it is going to be at the midpoint of the size given. So therefore here, this distance CG is going to be at 40 mm, okay? That is 40 over here. M by 2 is 40, N by 2 is 25. Is that okay? Is that okay? Ny is equal to N1, that is equal to 25. And here it is, M by 2 is 40 mm, okay? Are you there? Are you people are there?
Yes, sir.
Yeah, please check, please check. So this is the difference between the other joints. So if you have straight welded joints, I mean like parallel fillet welds, transverse fillet welds, like what you are given in the data handbook. So only for L joint and C joint, you need to find, locate CG, okay? Otherwise, diametric center itself is going to be your CG over here. So therefore, N1 is equal to Ny is equal to 50 by 2, that is N by 2, okay? And this is width of the plate is 80 mm, so therefore M is equal to 80, and therefore M by 2 is 40. This is M, this is N, okay? This is the CG. This is M by 2. And this is N by 2. Okay? Are you getting this size of the weld? Anybody? Any doubt? Okay, completed. Tarun, finished up. Jain?
Yes, sir.
Sai Sumant?
Yes, sir.
So the last
sir, done.
line, can you show, sir?
Pardon me?
The last line of this slide.
Yeah.
Okay.
Yeah. Okay, so tomorrow we'll take another type of welded joint, and Saturday I think we'll be completing this welded joint. Is it okay? Done?
Yes, sir.
Okay, then please study, right? So put your efforts, study, okay? And okay. Okay, we'll see.